The business of living involves communicating, which often means conversing. And in today's active mobile world, conversing more and more often is by telephone. The phone brings people closer together, helping to answer questions and solve problems quickly. What happens, however, if we're on the move? Today, cost and other limitations make it difficult for most of us to have a mobile telephone. That's today, but what about tomorrow? For several years, Bell Laboratories engineers have been working on a mobile telephone system that will be economical, reliable, and able to serve more people than the present system can accommodate. This new and efficient system is the Advanced Mobile Phone Service, or AMPS. A high-capacity system that will offer service to thousands of customers. Essentially, mobile telephone systems have been and still are two-way radio connections between a telephone in a vehicle and the regular telephone network. The first mobile system, developed in the late 1930s, used a push-to-talk telephone handset connected to a radio transceiver in the vehicle. A mobile service operator connected the calls to the regular telephone network. This special operator kept track of the channel each mobile caller was using and could not reassign the channel until the call had been completed. All land transmission was handled from a single high-power transmitter positioned at a high elevation near the base station. The transmitter was located in the middle of a mobile service area, called an MSA, roughly 20 miles in radius. Two or more receivers were situated throughout the MSA to pick up signals coming from the lower-powered transmitters in widely scattered vehicles. In 1946, 21 channels were available in the FCC allocated frequency bands. 10 channels in the 35 megahertz band, only 2 could be assigned in any given area, and 11 channels in the 150 megahertz band. In 1952, another allocation by the FCC made 12 additional channels available, this time in the 450 megahertz band, bringing the total number of channels to 33. In that early system, only a portion of the total number of available channels in any one frequency band could be assigned to a single MSA. These same channels could be reused in other MSAs, but only when the separation distance was about 100 miles, or roughly 5 times the radius of the coverage circle. Only a few of the channels available in a single frequency band were assigned to each MSA, so only a few conversations could be carried on simultaneously in that area. In any given MSA, customers vying for service greatly outnumbered the available channels, forming in effect giant party lines. With so many customers often competing for a channel, many calls simply could not be made because, more often than not, the line was busy. The Bell system has made many technical improvements that are reflected in today's system. In most areas, push-to-talk has been replaced by the simultaneous talk feature. Automatic channel selection and dial tone are also available. But the number of people who can use the system remains extremely limited. The Bell system's primary goals in developing tomorrow's advanced mobile phone system are to supply mobile service to more people, to improve the quality of mobile communications, and to lower the cost. The FCC made these goals attainable by allocating to common carriers an additional 40 megahertz bandwidth centered at about 850 megahertz. In AMPS, this band of frequencies is divided into 666 channel pairs with a 30 kilohertz spacing between channels. With the additional 40 megahertz bandwidth, Bell Labs engineers can make more efficient use of the radio frequency spectrum in these ways, by using low-power transmitters in the mobile units and now in the base stations renamed cell sites, and by subdividing MSAs into smaller units or cells. These cells range from 1 to as much as 8 or 10 miles in radius. Thus, AMPS designs achieve a spectral efficiency not possible in present large cell arrangements. The hexagonal shape of the cells is a convenient way to represent areas without overlapping or leaving areas uncovered. Each cell set or group of 7 cells is a complete unit in that it can use all 666 available channels. Let's letter these cells A, B, C, D, E, F, and G. Cells adjacent to one another must use different channels. But the same channels can be reused simultaneously in different cell sets when the separation distance is great enough. For instance, if a G cell handles channels 4, 5, and 6, all the adjacent cells must have different channel assignments. However, all other G cells, because they are sufficiently far away, can handle channels 4, 5, and 6. Depending on population density, the number of channels assigned to a cell varies greatly. Relatively few channels in outlying areas, and perhaps as many as 96 channels in metropolitan areas. In all cases, in amps, the total number of channels in the 7-cell set cannot exceed 666. As the number of customers increases, cells can be subdivided or split so that more customers can be served. A characteristic of FM transmission, the so-called FM capture effect, makes cell splitting practical and directly relates to wideband FM modulation techniques. Whenever an FM receiver gets two signals at the same frequency, it locks onto the stronger of the two, shown by the direction of the arrow, and suppresses the weaker signal. Even though cell splitting proportionally increases the strength of the signals, both desired and interfering, their relative strength is not affected. While considering cell size, let's look at reuse ratio, the relationship of the distance between two cells assigned the same sets of channels and the radius of those cells. For purposes of our discussion, we will use a typical reuse ratio of 4 6/10. Then, if a cell were to have a radius of 4 miles, another cell with the same channel assignments must be at least 4 6/10 times 4, or 18 4/10 miles away. If the cell's radius is split in half, a cell assigned the same set of channels will only have to be 9 2/10 miles away. In today's system, with each coverage area having a radius of about 20 miles, a channel used in one area cannot be reused for about 100 miles. Or said another way, a channel assigned in New York City cannot be reassigned until Philadelphia. In amps with 1 mile radius cells, a channel can be used many more times in the same area. Growth of the system is handled in two ways. As an area becomes more densely populated, cells within that area can be split and, when necessary, split again to increase service. To extend service to outlying areas, new startup cells of an 8 or 10 mile radius are simply added on and appropriate channels assigned. Another major factor, in addition to the cellular concept, that makes the Bell System's advanced mobile phone service a practical approach for mobile service is the electronic switching system with its large capacity and stored program logic. Acting as the Mobile Telephone Switching Office, or MTSO, electronic switching offices handle the connection into the landline telephone network and the large number of automatic control features that are required in apps. These include locating the vehicle and the particular cell in which it is operating, identifying and alerting the vehicle, selecting a voice channel and completing the connection, measuring the signal quality, and changing channels when the vehicle moves to another cell. Setting up and managing the call and computing the charges are also handled automatically by the system. Most of the customer service features offered with regular landline service will also be available in the future system. Speed calling is now being offered in Chicago, where the system is being tested, and other features will be added as needed. In addition to the MTSO, a cell controller in the cell site and a logic unit in the mobile vehicle are also parts of the logic and control structure, relaying information back and forth between the MTSO and the vehicle. The operations handled by the MTSO would take many more steps if it were not for the presence of a tiny computer known as a microprocessor located in the mobile's logic unit. The use of this solid-state device makes the mobile unit an intelligent piece of equipment, performing a great number of control functions on its own. To get a better understanding of how the AMP system works, let's take a look at a typical call sequence. The mobile radio operates on two types of channels, voice and setup. Voice channels are used for talking. With special audio coding, they can also carry necessary control information while a call is in progress. Setup channels, as their name implies, are used for all call setup functions. When the mobile set is not in use, the mobile radio tunes to the strongest setup channel so that it is always alert to an incoming call or prepared to initiate a call. To make a call, the mobile customer dials the desired number. After dialing is completed, the customer presses the send key. The dialed digits are transmitted to the mobile's logic unit, which relays the data message to the cell site. The cell controller, in turn, relays the message to the MTSO. Then the MTSO assigns an available voice channel and instructs the mobile radio through the cell controller to switch to that channel. All communication which is required to initiate a call is done on the setup channel. The call itself is conducted on an assigned voice channel. Sometimes it is necessary to reroute the call through a different cell to maintain a high-quality radio link. This rerouting process is called handoff. The MTSO considers the signal quality of the call channel and determines if the mobile should be handed off. If a transfer is necessary, the mobile is handed off between cell sites, so it can be served by the cell site with the best signal quality. During the conversation, the MTSO scans the signal coming from the mobile vehicle to see whether the call has been completed. Since the MTSO scans the signal every few milliseconds, it knows almost immediately when the call is finished. The channel is then available to another customer. Upon disconnect, the logic unit in the vehicle reverts to scanning the setup channels, again always alert to another incoming call or prepared to initiate a call. When a regular telephone customer dials a mobile customer, the number is routed through the local telephone switching office and on to the MTSO. When the MTSO receives the number, a paging signal is sent out from all cell sites to locate the mobile customer. Upon recognizing its number, the mobile radio responds on the setup channel with a request for service message. A talking path is then set up through the cell site where the mobile unit's message came from, and the call is connected to the mobile customer. From this point, the call is treated the same as it was for the mobile-originated call. The call is handed off when the mobile's movement through the service area requires it. The call is terminated when either party disconnects. While the system is taking care of the operational steps, including locating and alerting the vehicle, selecting the channel, making the connection, handing off, or detecting a disconnect, the mobile customer is never aware of the complicated processing that is going on. The result is that mobile customers can make calls in almost the same way as they would in home or office. What does all this mean for tomorrow's mobile telephone customers? First, they will almost always be able to pick up their handsets and get a connection. Second, mobile customers will be able to make and receive calls during an entire trip rather than during isolated portions of the trip. And mobile service will be available at a lower cost to those who want the service. Today, the Bell system is conducting a service test in Chicago. In addition to testing amps with a heavier load, the Chicago test will provide information on service needs and calling habits. This first cellular system will also help us evaluate system operations, confirming that equipment and control software interact properly. Thus, through the use of the small cell concept and complex solid-state circuitry, and with the total integration of computer control, the Bell system's advanced mobile phone service makes the best use of the recently allocated frequency band. Using and building on existing technology, the AMP system is tailored to the needs of the public. A service such as this will truly be a mobile extension of the nationwide network.